Welcome to Today in Space, the all things space science podcast where we follow and share the most exciting things in the industry, in the busy and ever-evolving space industry. One, because it's awesome, and two, so you don't have to. I am your space science podcast host from the East Coast, Alex Giarfanos. We're recording this from planet Earth on Earth Day, April 22nd, 2023. This week, we're talking about Starship and the first integrated test flight. There's been a lot of coverage about this flight, and we'll share our take and catch you up on all things Starship. And we'll close with some space story time about Sergei Korolev and the original heavy lift rocket, the N-1 from the Soviet era, which is the only real comparison to the Super Heavy booster and Starship. So let's get into it. Before we start, if you like what we're doing here, here's how you can help support us. Share and spread the word. It's free, and a share, like, or subscription is easy, and it tells the algorithm that it's interesting enough to share with others. You can also get a gift through us at ag3dprinting.etsy.com, which is our Etsy shop where we sell 3D printed gifts. And of course, if you're looking to start your next 3D printing project with us, you can get a free quote at ag3d-printing.com. We'll see if we can help you out. And of course, you can support us through our sponsors, Manscaped and Caldera Labs. For both, you can use code word SPACE for 20% off, and you get free shipping with Manscaped. So without further ado, let's start the show. Thanks for joining us. Let's talk about Starship. All right, so let's begin right off the top. Let's talk about what Starship is. So Starship is SpaceX's fully reusable option to be able to send enough mass into space that would allow us to go to Mars and make life interplanetary. What Starship's goal is to really make the holy grail of rocketry, which is, being able to carry multiple hundred tons of payload into orbit, right? 250 metric tons of expendable use if they wanted to. That's a lot of mass sending in things into space. And not only would it be able to just send things, it's also designed to send humans. Right now the capabilities of sending people to space is roughly 4, potentially 5 or 6 in the coming years here, but Starship would be able to potentially send up to 100 people at one time to go to Mars. It's the Starship is made of 2 parts, and that's what this test was really about. It was the first time that the Starship, which is the first stage, which would carry the humans, which would carry the payloads, and would land on the moon, that is sent up into orbit off Earth thanks to the Super Heavy booster. So Starship itself, with both fully integrated and stacked, is 120 meters or 394 feet tall. There's a 9 meter or 29.5 foot diameter, and the payload capacity is 100 to 150 tons fully reusable, which means that you could land this thing, both the booster and Starship, and you'd be able to keep doing that. And right now, not only is sending up that much payload really difficult, if not impossible, with the technology that we have today in one launch, if they get this right, because again, this is still in development, if they get this right, not only would we be able to send larger things into space, which opens up our design capacity for what we send into space. Right now, it's, and by the laws of physics, it's a game of minimizing your mass and making sure that whatever you send up there is rugged enough, sturdy, and will not break from the pressures of leaving Earth's atmosphere to get it there. And you have to make sure that you are really efficient in your power. Like Starship opens up that capability. James Webb Space Telescope was folded into pieces and then unfolded into space so that it could fit the spacecraft that was available to send it into space. So this could potentially change the whole way we look at things. And not only that, it would enable humanity to go to other places like the moon, which it's going to be used in the Artemis 3 mission for NASA to send the first woman and the first person of color to step foot on the moon. And so this first test launch is the first time that the Heavy booster and the Starship were used together, and they tried to go into orbit. Now, the goal of the mission was to see if they could, in their countdown, fully fuel this Starship stack so that they could get it ready for launch. They had an attempt before April 20th where they tried to do this and they missed the launch window. Something wasn't right. A pressurant valve got stuck and was frozen because they're putting in cryogenically cooled fuel, liquid fuel, both methane and oxygen. They're putting that liquid fuel in there, making sure that it actually flows correctly, because there are 33 engines on that Heavy booster. That is not only, I believe, the most amount of engines on a single rocket, but it's also the Starship is the heaviest thing ever sent into space. So all of those Raptor engines, those 33 engines that are on board that first stage, really needed to light perfectly in order for this massive thing to go into space. And that didn't happen. But the real expectations, and we heard this from Elon Musk himself, was that, and maybe I heard this, but this was also my low expectation of this test launch, because that's exactly what it is. It's a test launch. This test, what it basically had to do was have the actual mission start, light the engines, and take off from the pad and not blow up on the pad. And as we'll talk about later in this episode, the reason I had thought about that was that there's a very, it's a world record. It's one of the, not a great world record, but it's the largest non-nuclear explosion that's happened on Earth. And it was from the N1 rocket exploding right on the pad. And we'll get into more of that story here, because that rocket, the N1 rocket, is really the only rocket that really compares and that we can look at and see the challenges of the N1 rocket, which never was able to send Russians to the moon because it failed. But we'll talk about that later. So the Starship, for the test and the way that SpaceX does things is all based around this iterative process about, you spend your time in the theory and the physics to figure out what the design is. Then you manufacture this rocket and these engines to the best of your ability to that theory. But then ultimately, you have to put this thing into space. And really, getting to space and being able to get that data and figure out how your rocket works in real life under real conditions is super important. And what SpaceX does is they get that data along the way. They don't wait to have the perfect rocket built to do so. They get it in stages. And let's take a break from this episode to talk about our sponsor, Manscaped. So Manscaped has all the tools you need to get your male grooming done, whether it's your beard or hair, anywhere else in your body. Be the perfect specimen with Manscaped. Look, if you're like me and you work in engineering and you're working hard, or wherever you're working, you've got to be prepared for the alien abduction at any time, or if we get any kind of alien visitors. Look, if you're trying to get off this rock and go to another planet, I get it. I understand. But your chances go way up if you're representing humanity well. If you're a good human specimen, then, if you're trying to hitchhike across the galaxy here, the only way you're going to get picked up is if you're a good human specimen, right? So let's get the right tools for the job, all right? So manscaped.com, go there, use code word SPACE, get 20% off and free shipping on anything in the store. We've been using the Beard Hedger Pro here to keep our beard nice and full and trimmed up and adjustable throughout the week. One blade, one comb piece, 20 adjustments. There's also the Weed Whacker 2.0, which is for the nose and ear hairs. And of course, you've got the Lawnmower 4.0 for everything else. Manscaped.com, code word SPACE, 20% off and free shipping. Represent humanity. Do your part and be ready for an alien hitchhiker to pick you up by going to manscaped.com, code word SPACE. Thank you, Manscaped, for your support. And now back to the show. And that's been the story. We've been following SpaceX. We followed the Falcon 9 development early in the early days, and watched as they had, in the original days, they had rigid legs. It was called the Grasshopper on the Falcon 9, and they were just basically showing us that they could control a rocket going vertically, hover, and then come back down. And a lot of those blew up. And it's very different. It's a stark contrast to what NASA has shown us, and really what I think the population of human beings are used to is seeing the one-off, one-go. You either succeed, or for many that remember this, or if you're so young that you weren't alive during the space shuttle era, or you were too young to remember, most people think that when you blow up a rocket, it means that people died. So there is this event was kind of exposed how much work there really is out there for people to understand what a test flight means in space. They haven't been shown it, so they don't know that it happens. But NASA blows stuff up too, but they try not to because of their exposure and the fact that they're a government-funded agency. They are showing off the nation's capabilities, and a lot of this stuff, people don't want to share that information because it is at its core missile technology, right? Projectiles. And so we're very lucky that we live in an age and have a company like SpaceX that shows us what happens behind the scenes and how things are tested. That's why in the event people are so excited, because this is just how they do things. The Falcon 9 did not work successfully the first time, and it took a while before they could not only launch the Falcon 9, but actually land the Falcon 9. That took a lot longer. But now they have a fully reusable workhorse down in Florida that's able to bring things into space at this point every 4 days, which is wild to have that many abilities to go to space. But the early days of Starship started with the Starhopper, and this Starhopper is still at Starbase and sits near the launch pad for Starship and is hooked up with sensors and cameras so that it can view the launch itself. So it's an icon. It looks like R2-D2. So Starship was the first time where they equipped it with a Raptor engine and tested gimbaling and adjusting, but they were able to hover and land. And when they were done with that prototype, it became legend. Then they moved, this is an older Starship prototype, but then they moved to the booster configuration. And the booster that flew on this first integration flight was booster SN24. So the 24th version of the Starship, and it took many tries to even get to this point. And this Starship 24, this had been fueled and static fired and fueled and static fired many, many times, and they were trying to install engines and uninstall them as they saw any kind of performance issues. And there's people like NASA Spaceflight that's been covering this, Lab Padre down in Boca Chica, Texas. There's a bunch of people that have been following this, setting up cameras and watching Starbase as it starts so that we can get images and videos of them testing this. And they've even gotten so good that they've reverse engineered the whole countdown based on what they see on the regular in testing and what SpaceX reveals to the public. So Starship has come a long way. To get to this test flight, there were many, many failures and success that happened along the way, but this was the first time that the two were put together. So again, going back to expectations, they were pretty low because, we've seen them fuel, we've seen them static fire, so I wasn't too concerned with whether they were going to be able to light the engines. The question was, will they be able to create enough thrust to get into orbit? And then the first stage would have tried to do a boost back burn to turn the booster so that it could try and attempt a soft landing into the ocean. That would have gone into the Gulf of Mexico. If it didn't sink to the bottom, which was the plan, they were going to open the valves to bring in the water. And if that didn't work, according to NASA spaceflight, they were going to use a projectile to impact the rocket so that it would sink to the bottom. And I think that would have been a fun job. But the booster didn't make it there. Starship would have continued into orbit, would have fired its engines after stage separation from the Super Heavy booster, and then that would have basically impacted the ocean, but tried to do a belly flop maneuver to test out the tiles. And this would have been filmed, and there would have been data going back and forth. And so basically, what a test flight for something like this is a big demonstration of showing how it works in real life. And there were NASA planes in the air to take video. There were multiple different angles. SpaceX had data coming back in from the spacecraft, and they're going to compare that with what they thought would happen. That is, at its core, a test launch. And so when we try and grade how SpaceX did on this, we keep all of that into perspective. So what I'm going to do now, and for those who are on YouTube, you guys can follow along, but we're going to be showing the sped up version of the launch. We're going to do a quick, I believe it's, let's see, it's barely a minute and a half. So we're going to play this. I'm going to talk about the launch a little bit. Okay, it's 2 minutes. And we're going to do a quick launch breakdown and talk about what went wrong and what went well. So at liftoff, they put the launch on hold at T-40 before they lit the engines to see if everything was all right. They quickly turned it around and said, we're good for flight. Let's send this thing. And then they let the countdown continue, and that's where we pick up. All right, so the Super Heavy booster has 7,590 tons of force for thrust, 16.7 million pounds of thrust. And one of the interesting things right before we click this so that you get a perspective on this video, SpaceX, since they're developing this, they're trying to keep the costs down. One of the things that they have decided that they didn't need to add to this launch base immediately was a flame trench. Now, a flame trench redirects the force of the thrust coming out of the back of the rocket and is really important to making sure that extra debris doesn't fly around. So before we start this and we talk about what went wrong, it's important to know that there was not a flame trench. And if we look at this video that Felix Schlang put up from What About It, which is crazy, one of the NASA spaceflight minivans got hammered with rocks flying from this. So I'm going to play this so we get an idea of just how much energy was displaced, even though not all the rockets launched, which was part of the reason why it didn't get to space. So we look at this and we see the rocket's light. The van gets impacted by huge boulders, and then you see things that you've probably only seen in movies, right, of just giant boulders and rocks flying at crazy speeds. I mean, this is why you have keep out zones for launches, right? But just insane amount of force behind this thing. You know, almost 16, 17 million pounds of thrust. That's wild. It is the most powerful rocket ever built, and you can see this power on display and how important it is to be able to control it. So let's break down this launch. All right. So one of the things that happens, we saw that force and all that impact. Right away, there are 3 Raptor engines of the 33 that are not working. So one could argue, was this an ignition issue, a flow issue? Did not enough propellant get there that the engine couldn't fire? We see engines failing on the way up. So they end up losing 3 initially and another 3 during the launch. And you can see they're all kind of over on one side of the rocket. We have 5 right now that are down. We're going to lose another one in a second. So you start seeing the rocket almost immediately. You see that the direction of the thrust for the rocket, this is the most heaviest thing we've sent to space, it's not directly in line with the trajectory, which means that it's burning more fuel. It has to apply more thrust because it's not in the right direction. And so we start seeing it, and the attitude control over adjust, and there's just not enough thrust there. With 6 of the 33 engines knocked out, it starts pinwheeling and rotating, and you know, we saw the angle of that, of where it was pointing and its attitude, not good. But they keep this going because they're getting data. The engines are sending back data of how the thrust is working. The attitude control system is trying to adjust, even though it doesn't have enough thrust. That's still data that they need, but they detonate it with the onboard explosive devices for this event so that there's less of a chance of big debris hitting people and impacting people, although they plan that ahead. But we see, like, the people there, the people that work there, that live this day in and day out, this is their mantra. The mantra is, let's blow stuff up in the journey of figuring out how we can do this crazy thing about basically unlocking our ability to go into space and live on other planets. And NASA contracted SpaceX as the Starship being the option to send the humans down to the surface of the moon for Artemis 3. And so that human landing system contract, there were multiple competitors. There was Dynetics, there was Blue Origin, and they're now competing for future contracts because Artemis as a program is NASA's plan to make human life, more routine in space, right? It's going to break ground with sending the first woman and the first person of color to the surface of the moon, but there's going to be something called the Gateway built, where it basically puts us a space station around the moon so that we can go there and dock and then go back down to the surface, but we have an operation set up that can become more routine. And that's the only way that we're going to get to the point where you and I can go into space on the regular, just like we buy a plane ticket and fly around the world, right? That only happens when test pilots like the Artemis 2 crew and beyond that are putting their lives at risk, but working to making it so that they survive and we make this a thing that we can do more regularly. And then at some point, they'll put a gateway, ideally, around Mars, and that would make the journey to Mars and the landing to the surface two separate things, which reduces the complexity and makes it so that we can make it more of a robust thing. We take another break from this episode to talk about our sponsor, Caldera Lab. Now, Caldera Lab is here to help get your men's skin health in order here, okay? So what Caldera Lab does, you're getting a great quality product with none of those extra fillers that everything else seems to have, all the plastic that's involved, and the synthetic stuff added to these cleansers that probably end up making your skin worse, right? I've been trying Caldera Lab's Regimen and Icon bundle. The Clean Slate, I use that every morning when I'm in the shower to clean my face. The base layer, I put that on after to make sure that my skin stays hydrated and isn't flaking all day and I'm not brushing off dandruff or like flaky skin throughout the day. And it's been great. Honestly, it's been really enjoyable. And let's be honest, if you're a guy, you're a nerd, you're listening to this, let's be honest. Are you really taking the next step to take care of yourself, or are you just kind of like plowing through life and trying to survive? Look, that's okay. But why have to suffer through it, right? So taking care of your skin's a big thing. It's your largest organ, right? And the instructions here are so simple. That's why we love Manscaped as our other sponsor. This with Caldera Lab is great too because it simplifies taking care of your skin. So what we found was really interesting was with those simple instructions, I realized that, like with the Clean Slate, when I'm washing up in the shower, it says to wash your face and the back of your neck. And I realized, when was the last time I washed the back of my neck? Like, honestly and purposely. It was a very long time, surprisingly long time. And so I point it at you and I say, hey, what about you? When was the last time that you also washed the back of your neck and everywhere else and actually took the time to do so? Caldera Lab makes that easy so you don't have to think about it. And they've got great stuff. They're committed to transparency, sustainability, and they say excellence. They're on a mission to make men's skincare around the world better. Clean ingredients and a scientific process to back that up. Use code word SPACE at Caldera Lab. Get 20% off by using the code SPACE. 20% off, code word SPACE at Caldera Lab. Join the better skin journey that we're on as well by joining us. Again, 20% off, calderalab.com, code word SPACE. Wash the back of your neck, all right? All right, now back to the show. Thank you, Caldera, for sponsoring us. Now, if we go back to how we're grading Starship on this, you know, this got about halfway there, right? The rocket got past max Q, which is the real moment, one of the biggest moments of going to space, which is when the rocket's trying to scream its way out of the atmosphere. It's trying to accelerate away from the acceleration of gravity. It's losing mass and gaining speed. But there's a point where, as you're hitting the atmosphere, that friction, that the pressure that you're experiencing is called the maximum dynamic pressure. And that's when the rocket is vibrating, the air around it is squeezing around it, trying to rip it apart, basically, as the rocket's trying to tear through the atmosphere. And, you know, it breaks the sound barrier. And max Q is that event that you want to get by. It got by that. And Starship stayed together with the Super Heavy booster, even through all that pinwheeling. It didn't rip apart and become a disaster. They ended up killing it. Although I will say the pinwheeling is not what you want to see a rocket do. And that's why I would call this a very successful failure. I call it a success because there was a great attempt at gathering a lot of data, and they did not blow up on the pad. And we'll talk about how that affected the N1 in just a bit here. But to close out our thoughts on Starship, it was a successful failure in that it was marketed and demonstrated, and the test was that Starship was going to go orbital. And so if we're going to call it a failure, it's a failure because it did not get orbital, because Starship did not separate from the Super Heavy booster. That, to me, makes it a successful failure. Successful in that data was gathered, it did not blow up on the launch pad and delay future tests of Starship so that, you know, in a few months, this summer, early fall, we could see the next booster. The SN25 is at Starbase right now, and they have multiple productions going along the way. Depending on what they find, we might see that they change the plan. They may change how something is designed, which may affect future Starship productions, but they're building up all the operations that they need to make this fully reusable, which is more than just sending it into space. So the thing about this first test is I think it gives us a really good opportunity. It's more progress than I expected them to make in 2023. So they're already ahead of that. I think if they can get 2 more attempts at Starship, and if the next one goes very, very well, then I think there's a good chance that the Artemis 3 mission might be possible. But we'll see. There's a lot of work that needs to be done. We still don't have the whole story of what happened because those engineers at SpaceX are digging through that data, and I'm sure every one of the teams and all their different specialties, from usability to trajectory and propulsion and structures, all of those folks are trying to get as much data as possible. And the minds behind the Falcon 9 will most likely be brought in for the minds working on Starship, and they're going to integrate all of that knowledge so that they can make this next attempt very valuable and opportunistic. The big thing is, if this is going to be sending humans, blowing up starships without a plan for making that not happen the next time, or without a solid plan in order to do that, I think the best thing that they can do for Starship and Artemis 3 is get the next one to separate and start showing as much as possible the ability of Starship to make it so that the human lives on board will be safe. Starship, we've seen it launch and land before. We haven't seen it in an abort scenario. We haven't seen it in anything other than a controlled hop. So these are all things that they have to figure out, but they have so much data with the Falcon 9 that I'm hopeful that they'll figure this out. But a very, very impressive, successful failure for the first fully integrated space Starship launch. Didn't get orbital, but it got very, very close. So congrats, SpaceX team. That was incredible. And it was really cool to be able to show this with a bunch of people. I wasn't able to get down to Texas because coordinating time to be in Texas would have required booking 2 weeks once we found out when it was going to happen. And then when it happened on April 20th in the morning, I had the opportunity to share it with a bunch of folks, and it was very cool seeing everyone's reactions. And the biggest thing before we go into some space story time here that I noticed was really that iterative process, right? That idea of building and failing, but learning why it failed and making an adjustment, but getting a bunch of tries. Just like working out or learning a new skill, you're going to fail along the way. But if you can strategically figure out based on your failures, or fail strategically, right? That's kind of what this first test launch was a strategic failure. Not on purpose, but knowing that if it fails here, this is what it means. Let's get the data so we can figure that out. And 3D printing, as we have with our AG 3D printing lab here, is the perfect example of that iterative process. We have been using the iterative process to develop this podcast, but also to with everything that we do with our 3D printing lab, AG 3D, it's always about giving it a shot, seeing where it failed. How did the print we tried to do, why did it fail? Was it the way we made the model? Was it the way that we had the settings on the printer? Or is it something with the material? Like, there's always a mystery to be found with the iterative process. And if you like a mystery, you'll probably love the iterative process. So we have been working on rocket pens here. It's an idea that we had, and then we saw a few folks talking about it on Twitter. And so we started with the Falcon 9, which we have, and we're developing into a pen. This was my first attempt. It was larger. It kind of reminded me of those like fun big pens that you had growing up. And hilariously, this is the most reliable rocket pen that I've made so far, and it is one of the most reliable rockets that we have out there today, especially the one with the most launches, and more to come. The Starship pen was the one that we really fell in love with, and the hilarious thing is, so both these rocket pens use the same ink cartridge, and while this one was printed with fused filament fabrication, which is kind of the typical, if you've been in a maker lab or a lab at school and you've got like a desktop 3D printer, this is probably what you've seen before. So that's the one with the filament and the hot nozzle. Starship was made on a resin printer using UV light curable resin and building it up. We built it in 2 pieces, and then I put that ink cartridge in and sealed it up. And the cool thing about resin is you can just apply the wet resin, cure it with UV light, and now it's the same as the hard body that you just printed. So we did that. It's now one piece, right, with the ink cartridge in there, but I don't have enough ink thrust. It will print, and then I'll be able to write, but then eventually, after a little bit of ink, it seems to dry out or it stops writing, and then it takes a while. I have to put the pen down and start back up. So the mystery is, why is the same ink cartridge working well on this bigger one but not on this one? And I think what's going on is that in the bigger pen than the Falcon 9, there's a lot more space around the ink cartridge, so there isn't like a vacuum that's happening. I think on the Starship, there's a vacuum happening on this ink, which is causing it to not flow as much, and then that's why I have to wait, and eventually it'll keep writing, but it keeps drying up. So, that's the iterative process. So if you're wondering why SpaceX can blow up a rocket and still call it a success, that's why. Is because ultimately, this was going to blow up. It was either going to go into the ocean, into the Gulf of Mexico for the Super Heavy booster, off the coast of Hawaii for Starship, but both of them, this was their last launch. And for their last launch, they gave us not only a lot of data, but entertainment. I saw so many people take the failure so many different ways. It's a great conversation piece. I think launching into space became so routine, especially after 50 years of us doing it, right? And going to the moon and stuff like that. This is the new stuff. This is the entertaining stuff. Stuff where we don't know what's going to happen. We know that we stepped foot on the moon. We know that we did it. Do we know that we can create the world's most powerful rocket and make it so that we can go to Mars? We don't yet. But watching them try it is very exciting. So really, really looking forward to that in the future. And good luck to the SpaceX team. It's going to be those Raptors, and that Super Heavy is a beast. And I hope whatever happens with the launch pad, whether they're going to put a flame diverter in there now or not, we'll see. But having those big boulders shoot around, and the amount of debris that was created by this test is really shows you how big this thing is, how much thrust there is, how much explosive power there is behind this if it goes wrong, and just how much it can literally move the Earth with the amount of thrust it has. So, yeah, craziness. Looking forward to where it goes next. All right, so a little space story time to close things out. Thank you for joining us for this episode. If you're staying this long, you're awesome, and really appreciate it. But let's talk about the N-1 Soviet rockets. The N-1 was designed to go into space and to allow the Soviet Union to compete with the U.S. Saturn V. Now, the Saturn V rocket is not the same. Oop, this is backwards. Thanks to our friends at Estes, we have the Saturn V here. But the Saturn V is not the same thing as Starship, and the N-1 was not the same thing as the Saturn V. So the N-1 was in some places described as potentially a 5-stage rocket. The Saturn V was a 3-stage rocket. The Starship is a 2-stage rocket. But the really interesting thing, and there's a lot of data we can go into. We could talk about the thrust differences, the amount of engines. We'll touch a little bit on it. But I think, to me, the most important thing about the N-1 and the story behind the comparison between the N-1 and Starship and the challenges that Starship is going to face, and the N-1 is really where we should point this. And the story really starts with Sergei Korolev. So Sergei Korolev was basically the main designer, the head designer of a lot of the Soviet era rocketry. So the Soyuz system, right? Those boosters, traditionally, we see this happen with the Soyuz system, where those boosters will detach and they'll spiral out in a very specific pattern, and that's a Korolev maneuver. And what that does is it's optimizing basically the thrust for that rocket to go into space. But it's an example of just how influential Korolev was in rocketry, that Soyuz rocket, and that maneuver is still used today when that thing launches into space. Now, when this was first shown to be launching, the N-1, nobody knew that Korolev was the main designer. His name, I guess, was hidden. Again, this is all based on old articles that we had to go to a place where it still shows that stuff. It's called Wayback Machine. So this is the Wikipedia sources, and we're going through them here. But so Korolev was designing this, and there's one article here that kind of goes more into the story, and I'll read this. Take it with a grain of salt. This was released October 31st, 2016. It's a capture, so this isn't up anymore. But I think this captures it perfectly. So, on June 23rd, 1960, the USSR gave the go-ahead to the N-1 project via a decree, basically, that they wanted to compete with the U.S. It was to use liquid propellant engines. It was oxygen, kerosene on all stages, and the launch mass with the payload was 2,200 tons. Now, while this was happening, Yuri Gagarin was basically a year before going into space for the first time, to give you an idea of where we are in history here. And Yuri Gagarin, for those that are unaware, we just had Yuri's Night recently, was the first human being that went into space. And yes, it was a Soviet astronaut. But Yuri Gagarin is kind of seen, especially for those that celebrate Yuri's Night, as a human being. He's not seen as a Soviet as much as he is the first human that goes to space. And that's a beautiful thing that we have that as symbolism, and it's not just the space race and war and one country being better than the other. So Korolev was looking for someone to help design this rocket with him. Valentin Glushko was the person that was like the designer for heavy lift rockets. And so they had been friends, and unfortunately, I guess they had a falling out. And so Korolev basically had to go find another person to help design the rocket. And so he found Nikolai Kuznetsov, and he had a lot of experience with jet aircraft engines, but not rocket engines. So the whole reason that the N1 has all those rings of small engines is because it was easier to build a smaller engine than a bigger engine, according to this. So they also tried to create they called this the Kord system, KORD, which would control those engines moving. So, you have smaller thrust vectors that you're controlling each individually to make sure that this massive thing goes up into space. There were 4 test flights of the N1, and on the second one is where that world record of the largest non-nuclear explosion to ever happen on Earth, that's where it happened on the pad. Now, that pad destruction basically delayed any kind of progress for about 2 years, because now the thing that they would launch the rocket from is now destroyed and it needs to be rebuilt. Between the second and third launches, Sergei Korolev dies, and he had been, and this is kind of the storied, I don't want to call it a tradition, but a theme of working yourself to death, not only in engineering, which is of course the field that I chose, but in creative endeavors, in innovation and doing new things. There's kind of this trend of making sure that you don't work yourself to death and keeping yourself healthy while you're trying to do the insanely difficult or challenging thing that you're doing. I mean, it's not just space, but we see this a lot with space because of how hard it is. And as I was doing research about Sergei Korolev, I found out that, again, between the second and third test of the N1, Sergei Korolev passes away. And he passes away after many years of struggling with his health. He suffered a heart attack in 1960, and then he had a kidney disorder after he was detained in Soviet prison camps when he was younger. So his body was already not doing well, but he was also the main designer for the N1 and knew that if he wasn't able to get the N1 to work, then the Soviet Union couldn't keep the propaganda going and couldn't basically fight the US. And so he kept pushing himself. In 1962, his health problems were starting to stack up and was basically suffering from many things. His intestines were bleeding. And in 1964, he was diagnosed with cardiac arrhythmia, so his heart's failing, and then he has inflammation in his gallbladder. His body was essentially breaking down. And while his death itself is as most Soviet deaths, somewhat uncertain, what we know here is that in 1965, he was supposedly diagnosed with a bleeding polyp in his large intestine. And then he entered the hospital on the 5th of January, 1966, and they find a cancerous tumor in his abdomen. But Valentin Glushko, the old, no longer friend, said that he actually died due to a poorly performed operation for hemorrhoids. So, not to keep getting, classically dark here, but, with Russians, but he worked himself to death and was obviously not in a good environment. But that's the people that are at SpaceX that do this, the people that are at NASA, at these rocket companies, they work very hard, and their lives, it's so hard that their lives, the best ones, their lives center around this. It's built around being able to do this. So the story here is that the only comparable rocket to the Starship, the N1, its main desire, worked himself to death to get it to work. And Elon Musk is a classic work stacker who does many, many things at the same time. I mean, how many companies does Elon Musk have? He owns Twitter. He's involved in that all the time, which personally I think is one of the distracting things, but I get at a level why he's doing it. But this is something to be careful of. Starship is going to fail before it succeeds. Rocket technology is going to fail before it succeeds. So it really is a good reminder that, while there is a lot of people that say, oh, why would they launch and blow up a rocket, and having no idea really ultimately what is involved in making this happen, I am putting good vibes out there to try and hope that Elon Musk stays healthy, that the SpaceX team stays together, that the brilliant minds that are behind this rocket and making this work stay together and work together to do this, because you can see what happens when a rocket of this size, of this magnitude, of this kind of pressure does to a person and the human being. There are human beings that are making this rocket go to space and eventually bring us to Mars. So it's a reminder for me, because as I've learned through doing this podcast, and being an aerospace engineer and just an engineer where you are grinding and putting in hours and hours of work to get this physics of whatever you're doing to work, we all need to look out for ourselves. And after the pandemic and how many of us have changed the entire way of how we deal with our body and keeping ourselves healthy, it's a big reminder that this is a huge, massive goal, and they are going. I would be surprised if a lot of the team has slept more than a few hours at a time. There's so much that's being accumulated and gathered as far as this test. And what I hope is that they stay healthy and keep their minds right, as well as their bodies, and don't suffer the same fate as Sergei Korolev, who arguably was a great mind in rocketry, unfortunately for the Soviets, but worked himself to death. So to end on a less dark note, thank you for joining us for a little bit of space story time here. Again, we talked about the N1 and the story of the humans behind it, and really what is the same and different between the N1 and Starship. Now, if we talk about the history of the tests, so the 4 tests or launch attempts, the first one, February 21st, 1969, it explodes at 12,200 meters in altitude, 69 seconds after liftoff. July 3rd, 1969, at liftoff, a loose bolt was ingested into a fuel pump, which failed. And then the fuel pump's no longer operable. The automatic engine control shuts off 29 of the 30 engines, and that caused the rockets to stall. Then the rocket explodes 23 seconds after shutting off the engine, and then the rocket and the launch tower get destroyed in the biggest explosion in the history of rocketry. Korolev dies between the next attempt, those 2 years, 1969 and 1971, and on June 24th, vehicle serial number 6L has an uncontrolled roll after liftoff, and the control system can't compensate, and 51 seconds after launch, it blows up at an altitude of 1 kilometers. And the final test flight, November 22nd, 1972, just over a year later, vehicle serial number 7L, the engines run for 106, 107 seconds, and then the first stage engine cuts off at 40 kilometers. The program shut down of some of the engines. They were trying to prevent the stress on the structure. It leads to an explosion on engine number 4, and the vehicle is no more. So, yeah, we definitely had more success on this first flight than it seems that the N1 had in all of its attempts. But they still need to successfully get to orbit, and we need to start testing Starship and its landing and abort capabilities before we even put a single human being on there. But we're very excited to see what SpaceX does. They're the best at what they do, and they're going to have a lot of tries at this. So, SpaceX team, be healthy, take care of yourselves, and we'll get ready for the gauntlet that's coming on the way to the moon and to Mars. So that's it, folks. Thanks for joining us for this episode of Today in Space. As always, spread love and spread science, and we'll see you on the next episode of Today in Space. Be well. See you next time.